Has the Sense Foundation considered using some technologies that are sort of already present in the body? For example, you mentioned Alzheimer's disease, and recently this glymphatic system has been discovered, where now when we sleep, we know that cerebral spinal fluid squirts up into our brain and literally washes out the amyloid plaques and other buildup of these extracellular aggregates that are in our brain. Has the Sense Foundation thought of any way to use that system somehow?
We're looking at it. We're very interested in all ways of getting rid of molecular garbage, whether the garbage is intracellular or extracellular, and whether the getting rid of is destroying it on site or flushing it into a place where it gets destroyed in other ways. We're into all of this thing. We keep our eyes very open and our minds very open with regard to what's going to work.
That's really that's good to know. What about the new? I find this very interesting. The parabiosis, where we can scientists can take blood from a young animal and transplant it in an old animal and essentially reverse some biomarkers of aging in multiple organs.
Yeah, it's very exciting. We're actually funding a postdoc at Berkeley working in this area, in one of the top labs in this area. Of course, parabiosis itself is not a therapeutic regimen. We're not going to, I presume that you would not be too keen to be.
Right.
But it's definitely a great way to make discoveries.
Yeah.
And it, of course, leads to alternative versions like plasma exchange and pheresis, ways of taking things out of the old blood or putting things into the old blood so as to achieve the same effect that parabiosis would. Of course, in order to do that, you need to know what to take out or put in. And a lot of the problems that parabiosis research faces at the moment is that that's really laborious and tricky to find out in any kind of systematic way. The few hits that people have had so far in terms of factors that seem to actually have some kind of causal role, like GDF11 and so on. These things, were found more or less serendipitously, and everyone knows that there's likely to be a number of others out there, perhaps very likely to be ones that are more central to the effect, but which have not been found just because they're a little more counterintuitive.
So I envision, if these factors can be identified, GDF11, growth differentiating factor 11, was thought to be possibly playing a role in causing, muscle stem cells to divide and proliferate, and possibly in the brain as well. But others have not been able to confirm that. But
yeah, watch this space. That's going to run and run.
Yeah, I'm not sure. All I know is that I'm excited about the research in general, and whatever the factors are, I envision possibly making recombinant proteins. People are, using EPO or erythropoietin. Human growth factors. So some of the same sort of deal.
The big thing that needs to be taken into account here is that the factors that change in their abundance in the blood during age, whether up or down, and that may have an effect in terms of, if you like, transmitting pathogenic damage from one place in the body to another. Those things are, first of all, they're not necessarily just proteins. We also have to worry about cells, the fact that you have, changes in the relative abundance of different types of T cells, for example. And there's also small molecules, glutathione, things like that, things that may simply not be amenable to rejuvenation by measures like plasma exchange, but only by something like parabiosis. Then we would have to look at a different model. But I want to also emphasize something I just alluded to a moment ago, which is that we are talking here not about mechanisms whereby damage is created. We are talking about mechanisms whereby damage is transmitted from one part of the body to another. After all, that's what the circulation is. It just takes stuff from one place to another. It doesn't create damage. The damage comes from somewhere. So we always need to be looking out for the possibility that we can find the cells that are the source of the changes in the blood and change those cells back to a rejuvenated state, and by that means rejuvenate the blood.
Well, I think that the source of damage, in the sense of the circulation and the blood cells, and the immune cells in the blood are just that. When you activate macrophages, they dump out hydrogen peroxide and all sorts of reactive nitrogen species.
Yeah, that's not really what I'm talking about. I'm talking about, for example, let's take the thymus, for example. The thymus itself shrinks, as we were saying earlier, and that is largely responsible for the fact that in an older person there are fewer naive T cells and more memory T cells. If we can fix the thymus, then we fix that problem. And I can make many other examples.